Okay, so hello future engineers. Our topic for this week is about set theory. So let us first define what is a set. Sets are used to define a concept of relations and functions. The study of geometry, sequences, probability, etc. requires the knowledge of sets. So the theory of sets was developed by German mathematician George Cantor. He first encountered sets while working on the problems on trigonometric series. Studying sets helps us categorize informations. It allows us to make sense of large amount of information by breaking it down into smaller groups. So by definition, a set is any collection of objects specified in such a way that we can determine whether a given object is or is not in the collection. In other words, a set is a collection of objects. These objects are what we call elements or members of the set. The symbol for element is what we know as this symbol. So the following points are noted while writing a set. So take note of the following. The sets are usually denoted by the capital letters A, B, and S, or any other capital letters. The elements of the set are usually denoted by small letters. So for example, here in the sets below, we have set A, have the following sets A, B, D, 2, and 4, and so on. So sets, other ways to denote sets is using ellipses. So for example, if you are having a set of natural numbers, so you can write the set of natural numbers in this form. You have the curly braces, then ellipses will be used to denote that your sequence continues. So for example, in the set of integers, from your infinite negative to infinite positive, so you are going to use ellipses. Then sets can be well defined. A well defined set is a set whose contents are clearly determined. The set defined as colors would not be well defined, while the set of colors in a standard box of 8 crayons is well defined. So there are 3 methods used to indicate a set. First is through description, then we also have a roster form and a set builder notation. So description, through description means just that words describing what is included in the set. For example, set M is a set of months that starts with letter J. So that is an example of having your set through a description. So another one, we have through roster form or raster form. Raster form lists all the elements in the set within braces. Either we have element 1, element 2, and enclosed it in a braces. For example, we have set M is equals to January, June, July, close it in a curly braces. Then we have another way of naming or writing your set is through set builder notation. Set builder notation is frequently used in algebra. For example, we have already used this in our first or second week of discussion. For example, M is equals to, so this is read as set M is the set of all elements X, such that X is the month of the year and X starts with letter J. So I know you're already familiar with this and you have been acquainted with this one, so no need to elaborate with this one. So example, what is the set of all fingers? So our solution would be to list down all the fingers. So P is equals to, or any possible letter could be used. So we have the thumb, index, middle, or ring, or little. Note that there are other names for these fingers. The index finger is commonly referred to as your pointer finger. The ring finger is also known as a fourth finger, and little finger is often referred to as your pinky finger. Thus, we could have listed the set of fingers as the following form. It could also be used as a thumb, pointer, middle, fourth, and pinky, and then enclose it in a curly braces. So another example, let Y be the set of all continents of the world. So the best one to do these, to indicate the set or to write the set is to list down all the elements. So let us list down the set of all continents of the world. We have Asia, Africa, North America, South America, Antarctica, Europe, and Australia. So now let us learn about different and important parameters all about sets. So we have subsets. A is a subset of B if every element of A is also contained in B. This is written in the form so take note that if you are going to write subsets, you are going to use this symbol. For example, the set of integers having this form from your negative infinity to your positive infinity, so is a subset of real numbers. So formal definition, we have A is a subset of B, means if X is an element of A, then X should be an element of B also. So we have also to know the parameter which is known as or called as empty set. Set with no element. It is indicated by this symbol or this symbol. Elements may be sets. So take note that it is not only represented by a single number, a single letter, but it could also be represented, or you could have an element which is also a set. For example, we have 1, 2, and this 1 is your element, but this is a set. We have 1, 3, and 5 is a set. So we have 3. We have also a set which is 4, 6, and 8. So same with this example. Your element is a set. So now we will have a set size. This is called as your cardinality. So cardinality refers to the number of elements in a set. So it is denoted by this symbol which represents a size of a set. For example, if A is having an element 2, 3, 5, 7, and 8, then your cardinality will be how many elements does A have. So we have 1, 2, 3, 4, 5. So the cardinality or the set of yours, set A is equal to 5. If set A has a finite number of elements, it is a finite set. A set which is not finite is called as infinite. So we have to also know about the set relation. So you are already familiar with this one. So we have is a member of or is an element of. This is the symbol. So we have subset. This is the symbol. A is a subset of B. So every element in A is also in B. Next one we have superset. So A is a superset of B. Every element in B is also in A. So that is superset. Every element of B is also in A. Next one we have proper subset having this symbol. Is A is a proper subset of B. So every element in A is also in B, and A should not be equal to B. That is your proper subset. So every element in A is also in B, but A should not be equal to B. So proper subset. Next one we have proper superset. So having this symbol. A is a proper superset of B. Every element in B is also in A, and A should not be equal to B. So proper superset. Next one we have numbers in set. There are different types of numbers to be considered when we are dealing with sets. First, we have a cardinal numbers. Answer the questions, how many? Next one, ordinal numbers. It could be such as first, second, or third. So that is in order. Next one, you have nominal numbers, which are used to name things. Example of nominal numbers would be your driver's license, number of your student ID. The cardinal number of set S, symbolized as this one, is the number of element in set S. So if S is having an element blue, red, green, and yellow, then your cardinal number would be 4. As what was mentioned, that is your cardinality. Two sets are considered equal sets if they contain exactly the same elements. So they are equal if they contain exactly the same elements. So take note of the difference between equal sets and equivalent sets. Two sets are considered equivalent sets if they contain the same number of elements. So we are talking about cardinality, if we are talking about equivalence. So if they are equal, they should contain exactly the same elements. If they are equivalent, they contain the same number of elements. So for example, if E is having an element 1, 2, and 3, F is set F has this elements 3, 2, and 1, then the sets are equal since they have the same elements, and equivalent since they have both 3 elements. So pareho silang equal kay equal sila nga duha kay parehas ang gila nga element, and at the same time equivalent sila nga duha kay parehas tagtatlo-tatlo lang nila nga element. For example, we have if G, set G having an element cat, dog, horse, and fish, and H 2, 5, 7, 9, then the sets are not equal since they do not have the same element, but they are equivalent since they have both 4 elements. Next one, we have the power sets. So given any set, we can form a set of all possible subsets. So the set of all possible subsets is what we called as our power set. So power set or set A denoted as the symbol P open close parenthesis A. So let A is equals to this one. So our power set will be, so you should always include in your power set the null and the other elements. So that is your power set. So for example, you have the set A having an element A and B, then your power set should include a null, an a B, and A and B. So for example, you are having a set B with elements 1, 2, and 3, then your power set will be, first we have null, we have 1, we have 2, we have 1 and 2, 1 and 3, 2 and 3, and 1, 2, and 3. So that is for power. Next one, we have Cartesian product. So ordered pair is a list of elements in which the order is significant. Okay, so if we remember in our algebra classes, we are using this ordered pair. So we have, it is represented by this one. So we have a parenthesis, then we have separated by a comma. This is also similar to your set, but we are having your curly braces. So take note that if we are using set, the order is not significant. So next we have Cartesian product. Given two sets A and B, the set of all ordered pairs of the form A and B, where A is any element of A and B is any element of B, is called the Cartesian product of A and B. So example, for the Cartesian product, we have A, Cartesian product of A and B. So we have okay, for example, you are having a set A which have an element 1, 2, 3, and set B with element X and Y. So your Cartesian product would be a Cartesian product of A and B. We have the set of 1 and X. In ordered pair form, we have 1 and X, 1 and Y, 2 and X, 2 and Y, 3 and X, and 3 and Y. Next is Cartesian product of B and A. So B and A, you start with B, X and 1, Y and 1, X and 2, Y and 2, X and 3, Y and So you could also have a Cartesian product of the same set with itself. So we have B, Cartesian product of B and B, we have B squared. So we have X and X and Y and X, and Y and Y. Next one, we have set operators. So it is already presented in our previous discussion. So we have set operators. We have union. Union of two sets A and B is the set of all element in either set A or B. It is written in the form this one. So it is indicated by this one. X is an element of A, or X is an element of B. Union. Intersection of two sets. A and B is the set of all elements in both sets A and B. So the intersection of your set. So this will be presented more, and I do hope that you are going to understand this more if we are going to present this an example later on. So we have also difference. If two sets A and B is the set of all elements in set A which are not in set B. So set of all elements in A which are not in B. So written by the form A minus B. So this is also referred to as your relative complement. So complement of a set is the set of all elements not in the set. So this is represented or written in the form this one with small letter C as your exponent. Need a universe of elements to draw from. So set U is your universal set. So we are having the universal set here. Set with no common elements are called your disjoint sets. So their intersection is null. So then A and B are disjoint. If A1, A2, up to the A sub n are sets, and no two have the common elements, then we say that they are mutually disjoint. Next one, we have the universal set. The universal set is a superset of all sets under consideration as denoted by U. So for example, if we consider the set A, B, and C as the cricketers of India, Australia, England, whatever country would it be, then we can say that the universal set U of these sets contains all the cricketers or players of the world. So the union of two sets A and B is the set which contains all those elements which are only in A, only in B, and in both A and B, and this set is denoted by A union B. So A union B, so such that X is an element of A or X is an element of. So here are some important property of sets. So we have first one, the property of set and null. So the union of your set A and null is equal to A. The union of your A and your universal set is equal to your universal set. The union or the intersection of A with your universal set is equal to A. So the intersection of A with null is equal to null. Next one, we have idempotent properties. So we have intersection of A with itself is A. The union of A with itself is still A. So we have also commutative properties. A union B is equals to B union A. A intersection B is equals to B intersection A. So associative properties. So no matter the arrangement of your sets within the parentheses or the arrangement, so that is still, the answer will still be the same. So for as long as they are having the same operations. Next, you have distributive properties. A union of the quantity B intersection C will be A union B intersect with A union C. So Another one, intersection of this one, A intersection of the quantity B union C, that will be A intersection of B, so union with the intersection of A and C. Another one, the properties of your complement. So the complement of your null is your universal set. So the union of your set and its complement will be a universal set. So the complement of a complement of a set will be equal to that set. So the complement will be cancelled out. So the complement of your universal set will be null. So the intersection of your set with its complement will be equal to null. So we also have De Morgan's law. So De Morgan's laws will be the complement of the union of A, B, and C will be complement of C intersect with complement of B. So intersection of B complemented will be complement of A union with complement of B. So another one, we have absorption loss. So we have A intersect with A union B is equal to A union of the union to the quantity of the intersection of A and B will be equal to A. So just take note of this formulas. We are not going to apply this in solving for the problems, but just take note of the important properties of the set. So for example, we have this in order for you to better understand the properties of a set. So you could have a set of your 10 friends. Suppose you have a friend, we have the following list. So it is normal to use lowercase letter for them since they are treated as your element of your set. So we have Alex, Blair, Cassie, Drew, Aaron, Francis, Glenn, Hunter, Ira, and Jade as your friends. Each friend is considered to be the element of your set. So now let's say that Alex, Cassie, Drew, and Hunter play soccer. So we have write them in the form, so separated by commas, and then we have the curly braces. It says that set soccer is made up of the elements Alex, Cassie, Drew, and Hunter. So, and Cassie, Drew, and Jade play tennis. So tennis is equals to the set of Cassie, Drew, and Jade. So take note that this one, since this is the list of your friends, will be your universal set. This is your universal set. This is your first set. This is your second set. We can put their names in two separate circles. So for soccer, we have Alex, Cassie, Drew, and Hunter. For tennis, we have Cassie, Drew, and Jade. You can now list your friends that play soccer or tennis. So if you list and combine all this, we have, this is called our union. So the union of sets is a typical symbol of U, or the smiley. Soccer union with tennis, we will have Alex, Cassie, Drew, Hunter, and Jade. Just list down all the names here. So that is your union. So take note of the form in your Venn diagram. So the illustration here, or the figure here, is your Venn diagram. So take note that if you are going to draw a Venn diagram, it should be having a rectangle to represent your universal set. So we have soccer, Alex, Hunter, Cassie, Drew, and Jade. Next one is your intersection, is when you must be in both sets. So in our case, that means they play both soccer and tennis, which is Cassie and Drew. So the special symbol for intersection is an up-down U like this one. So this is how we write it. So we have in equation form, it is represented by this one. So in our Venn diagram, so this is our universal set and represented by this figure. You can also subtract one set from another, that is your different. So for example, taking soccer and subtracting tennis means people that play soccer but not tennis. So which is Alex and Hunter. And this is how we write it. So soccer minus tennis will be composed of the set made up of Alex and Hunter as your elements. So take note that if you will be asked of the complement of your set, so any member or any of your friends who is not playing soccer or tennis will be the complement. So any friends which are not playing soccer and tennis will be the complement of your set. So that is the concept of sets. So thank you everyone. God bless for your exams and stay safe.